Hello everyone, a very good morning to all of you, good afternoon, good evening. So in last session, we already discussed about few definitions of SI units, right? Meter, next kilogram, next second, right? Then next plane angle, supplementary, plane angle is also finished, mole is also finished, right? Ampere is also finished. So still two more definitions are left over. One is one supplementary unit, that is one supplementary physical quantity, solid angle. Another one is a fundamental physical quantity, candela. So after discussion of the solid angle, I will explain candela. Clear? Right? So you know very well, just once again I will revise the important things, golden key points, whatever we discussed in previous classes. Just only in a couple of minutes, I will finish it. You know x equal to nu. You remember this? Very good. X is equal to nu. What is x? X is nothing but measurement of physical quantity is equal to number into unit. And you know very well, x always constant, n inversely proportional to u means smaller the unit, larger is its numerical value. Okay, fine. The next, right? The next, in last class we defined plane angle. I told you how to remember that plane angle because of in entire physics, in most of the applications we are using plane angle concept. Right, in plane angle concept, just we have to remember length of an arc is equal to radius into angle. And you should be remember, you must remember this theta must be measured in radians. Measured in radians. 2 pi radians is equal to 180 degree. Pi radians is equal to 2 pi radians is equal to 360 degrees. Pi radians is equal to 180 degrees. Here in this theta must be in radians only. Right? That is what we discussed. These are now before going to start a new thing, just I will revise the most important point, whatever we discussed in earlier classes. Now the next one is a solid angle. Dear students, listen carefully. Solid angle, I feel it is difficult to understand this definition in student point of view, but I will explain in a proper way with some model. Don't worry about solid angle, right? What is mean by solid angle? What is mean by plane angle? It is the angle subtended by an arc of a circle at its center is known as plane angle. Plane is two-dimensional. Solid angle, it is a three-dimensional angle. What is the three-dimensional object? To define this solid angle, shall I take circle? Circle is a plane. For circle we are defining plane angle, that is a 2D. So to define a solid angle, we have to consider a sphere. Clear? Right. Then what is mean by solid angle? Solid angle nothing but, listen carefully, the angle subtended by a given spherical surface or a given surface area. You better to write a given surface area. At its given surface area of a spherical surface at its center is known as solid angle. Plane angle definition, it is the angle subtended by length of an arc of a circle at its center is known as plane angle. Solid angle is nothing but it is an angle subtended by surface area of a spherical surface at its center is known as a solid angle. So dear students, listen carefully. Actually sphere is three-dimensional, but board is two-dimensional. Okay, it is very difficult to visualize a three-dimensional on a two-dimensional plane, right? So consider, let us assume it is a sphere. It is the center of the sphere. Clear? Right. Now, we have to consider this surface area, that part of the sphere. You have to consider this part of the sphere. Wait, I will explain, don't worry. Then, you have to consider like this. Right? Then, this shaded part is nothing but it is a given surface area. Let us assume it is ds. Let us assume or ds or s or delta s. Let us consider s for this. Okay, or consider delta s. Okay. Delta S, I will tell you, sir, why you are taking delta S, delta S or ds. Generally we represent this symbol to measure a small value of that given physical quantity. Okay, for entire sphere I am considering only this much portion of the spherical surface. That area is not S, it is a part of the S. A small part of the S is represented by delta S or ds. Clear? Right. Then next, here what is this? This is nothing but R. Okay? Fine. Then, how to find the solid angle? Actually, SI unit of solid angle is what? SI unit of solid angle, steradian. SI unit of solid angle is steradian. The SI unit of plane angle is radian. So actually I want to define one steradian or a solid angle. How to define? Right? Listen carefully. Do you remember how to calculate plane angle? This length of an arc divided by, do you remember that formula? Theta equal to L by R. What is L? L is the length of an arc, right? R is the radius. Similarly, for a given sphere, for this given spherical surface, okay, this omega is a symbol for representation of solid angle. Omega is equal to, we can write like this. This is what actually delta S or ds you can write by square of the radius. This is what? Surface area upon square of the radius. This is the formula to find solid angle. Right? Wait. So for complete sphere, right? For complete sphere, what is the solid angle? So for complete sphere, what is the surface area? Complete for whole sphere. I am not asking about this much portion. I am asking about for complete sphere. What is the surface area? 4 pi r square divided by r square. R square cancel, right? Then solid angle for a complete sphere is equal to 4 pi. Very important relation. Please remember. in physics, in first year physics, we don't use this relation. Even in second year PUC also, only in two applications we are using this solid angle concept, right? So comparing with plane angle, solid angle importance is less. I will write where we use this solid angle concept. In electrostatics, second year PUC, in electrostatics, in electrostatics, in electrostatics, right? That is, concept is Gauss theorem. Gauss theorem, where we are using this formula. Means in second year, we have to wait for 1 year. Okay? Right. So still we are not at all understanding whatever you taught so far. You know artha agilla, sir. Please, one more time you explain if it is possible. Not one more time, wait, I will explain 2 or 3 times. So actually this is what the definition. Okay? Right. Now here I will show one model. Let us consider it is a sphere. Let us consider it is a sphere. Am I right? Sphere. Sphere. It is a sphere. Clear? Is it clear? Is it visible? Right. So here in this sphere, right, at center you have to consider, you have to imagine center. Then here I am consider only this much surface area of whole surface area. Whole surface area is yes. Whole surface area is yes. But I can choose only this much part of this sphere. For example, if you cut the watermelon, before purchasing that watermelon, when you are asking for a taste, they will cut one piece. Do you remember that? Right? They will cut one piece for taste. That part is, here I am assuming, it is ds. So still we are not understanding, sir. Okay, fine, wait. Listen. Now, whatever the part I am shown here, that part now here I am drawn again. Listen carefully. Listen carefully. So, here I am considering the part of the sphere, given surface of the sphere. Actually, whatever we consider that given surface area is ds. Once again I will show you. See, in this spherical ball, right, then I am considering only this much portion. That portion only again I am redrawn on this two-dimensional plane. Okay, so this portion I am considering. Right? Now listen carefully. Very, very important. Listen. Now, this angle. Now, this angle is nothing but d omega. It is the center. It is the center of the sphere. It is the given surface area of the spherical surface. Okay? Right? Then if you consider this part, right, for this part, then the angle subtended by this given surface area at its center is known as d omega. Sir, still we are not following, sir. Please, one more time you will explain. Wait. Okay? Right. angle is d omega. This is ds. It is r. So still we are not understanding, sir. Now consider cone. Clear? It is at the center of the sphere. Now this is the portion. See, this is the portion. This is the given surface area ds. Am I right? This is what is the given surface area ds. Right? Now here I am considering center of the sphere. So then what is a solid angle? What is a solid angle? Listen, what is solid angle? This is a solid angle. Clear? The angle, see, this is a solid angle. This is a solid angle. I will show you again. Listen carefully. The angle subtended by this given surface area at this center is nothing but a solid angle. I hope it is clear, right? So for a given sphere, I am considering this much surface area ds. For this ds, right? Then whatever the angle subtended by this given surface area at its center of the sphere is known as a solid angle. So how to calculate this d omega? D delta both are same. D omega, ds, just now only I told you, when we are using ds, d omega, nothing but it represents small value of that physical quantity. Okay, right, d omega, solid angle, omega, okay, you will write omega, it's not a problem, right, omega, ds, right, ds by square of the radius is known as solid angle. I hope it is clear, okay? Clear? So this much information is enough, because of in our PUC first year and second year, we don't want to use this concept repeatedly. Only in Gauss theorem we are using this concept. Clear? For board exam, only definition is important. This derivation, how you will get 4 pi, this is not at all required. Clear? You just remember, for one complete sphere, solid angle is equal to how much? 4 pi. For a given surface area of a whole sphere, how to find solid angle? Here you should write d omega or delta omega, both are correct. D omega, or here also you can write ds, no problem. I will tell you what is d. Wait, don't ask right questions on what is d, why you are taking d. Just remember, whenever I am using d or ds like dl, nothing but we have to take a small value of that physical quantity. You just remember like this. Okay, it is enough. So this is about the solid angle. I hope it is clear. Right? So solid angle, it is not a 2D, it is a 3D angle. It is a 3D angle. Okay? Right. I hope this concept is clear. So this much information is enough. Right. Now last one is candela. What is candela? Actually it is a SI unit of luminous intensity. Luminous intensity. Okay? Right. Then how to define this candela? So to define candela, first we must and should know what is a steradian. Right? Steradian, how to find steradian, sir? One steradian, just now only we find out omega equal to ds by r square. Okay? Omega is equal to 1 when ds is equal to 1, r square is equal to 1. Am I right? So, omega is equal to 1 means this whole value must be equal to 1. Right? Listen. So, now I am taking unit steradian. Unit in physics, unit steradian means 1. Unit second. Per second means divided by second. Per steradian means 1 steradian. Here I am calculating 1 steradian. Okay, so what is candela? Listen. So let us consider one sphere Let us consider one sphere. Okay? Then you have to consider one source of light. Source of light may be bulb or candle. Not candle, a candle. Okay? This source of light produce a frequency of radiation that is 5.40 into 10 raised to 12 Hz. Such a source we have to take. Right? Okay. Then this source must be not just 540. This source must be placed at the center of the sphere. Okay? Right. Then you have to consider this spherical surface. Like ds. This ds just now only we assume how much? 1. This is how much? 1. Then this one is how much? What is this? For a given spherical surface, what is this? It is the solid angle omega is equal to how much? It will become 1 only. Because of here we are taking this given surface area is 1 and the radius is also equal to 1. Right? Then it becomes 1 only, steradian, unit steradian. Right. So when we keep a source S of this much frequency, in this direction, it emits the radiation of intensity. Sir, what is intensity? Energy per unit time per unit area. Okay, now this source through this surface in this direction, in a given direction, right? In a given direction, what is the surface area? Unit only, 1 only. Per unit surface area, it emits the intensity of radiation that is 1 upon 683 watt. So what is watt? What is watt? Watt is a power of unit. Correct? SI unit of power. Right? So power nothing but work done by time. Now, if you keep a bulb or candle of this much frequency at the center, it produces intensity of radiation that is 1 upon 683 watt through how much? Steradian. Per steradian. Why 1 steradian, sir? Here this is how much? 1. Here it is how much? 1. Okay, that is known as candela. So candela is the luminous intensity in a given direction. Right? When a source of frequency 540 into 10 raised to 12 Hz produce intensity of radiation in that direction with 1 upon 683 watts per steradian is known as 1 candela. Now I will write the definition without any confusion. Candela nothing but it is the luminous intensity in a given direction. in a given direction of a surface that emits monochromatic radiation of frequency 540 into 10 raised to 12 hertz, and that has radiant intensity in that direction. In which direction you are considered? In this direction. So in this direction, this much frequency of source producing how much radiant intensity? Radiant intensity of 1 upon 683 watt per steradian. Okay, so this is about definitions of SI units, right? So you just remember this definition. Apart from that, we don't want, and in physics we don't use candela, right? But these are the fundamental base units of SI system. Okay, so you will just, in board point of view, in theory point of view, you just by heart these definitions. That's it. I think today's class is clear. Solid angle is somewhat typical. It is not easily understanding, right? Okay, so you just visualize that 3D angle. Whatever the angle is obtained by the given surface area at the center of the sphere is known as solid angle. That solid angle concept in PUC2 we are using in Gauss theorem. Just this much information, if you remember, it is very important. Alright. Now we are going to discuss about the methods of measuring of length. Right? So generally, in the beginning only we defined what is meant by physical quantity. Length is a physical quantity. How to measure this length? Measurement of length, measurement of any physical quantity can be done in two ways. One is by using direct method. Another one is indirect method. Okay, what is the definition of physical quantity? Do you remember? A quantity which can be measured directly or indirectly is known as a physical quantity. Yes, length is a physical quantity which can be measured or directly or indirectly. So I will give some examples, right? Definitely. Wait. For example, if you want to measure the length of this wall, how to measure the length of this wall? By using meter scale. It is the direct method. Okay? Right. Next. Listen carefully. This is what actually vernier calipers. I think, do you know in your school standard, I don't know exactly whether you discussed or not. So this is vernier calipers. What is the use of this vernier calipers? With the help of this vernier calipers, right, one can find what? One can find length of the cylinder. One can find the length of the cylinder. Chalk piece is the cylinder. Okay, length of the cylinder. Right? So to measure small distances, like such as cylinder, length of the cylinder. Okay. For example, if you want to find, like see, right? You know test tube like this. Test tube. Right? This is what actually open test tube. Okay, I want to calculate inner diameter of that test tube. How to find that diameter? Diameter of that test tube also we can measure with the help of these two jaws. If you keep these two jaws in a tube, then we can find out the diameter of that test tube. Okay, so this is also direct method. Next one is screw gauge. Screw gauge. Sir, what is the use of screw gauge? Screw gauge is used to find the thickness of the glass plate. For example, see, this is what glass plate. Right? Now I want to measure the thickness of the glass plate. So how to find the thickness of the glass plate? Right? So this is the way to keep the glass plate between the two studs. You will discuss all these things in practicals. Only for sake of better understanding of this, today I am using all these. So this is what actually glass plate. I want to calculate thickness of the glass plate. So with the help of this screw gauge, we can find out the thickness of the glass plate. Clear? And with the help of this screw gauge, we can also find out diameter, radius of this marble, radius of this small sphere. Is it visible? Radius of this small marble. Okay? So by using meter scale, by using screw gauge, by using vernier calipers, when you are measuring the length of a physical quantity, that method is always direct method only. Okay? So with the help of direct method, one can measure nearly around up to 100 meters, maximum 100 meters. With the help of meter scale, we can measure up to 1 meter is equal to 100 centimeters, right? Or we can measure up to let us assume some particular meters, right? But I want to calculate the distance between Earth and Sun. I want to calculate the distance between one planet to another planet. I want to calculate the distance between the two stations. I want to calculate distance between Delhi to Hubli. Then if you want to calculate the distance between Delhi to Hubli, shall I use this meter scale? Is it convenient method? Is it convenient instrument to measure the distance between two stations such as Delhi and Hubli? No. So that method of measuring the distance between Delhi and Hubli is indirect method. It is not a direct method. Like, rough idea I am telling you. If you want to calculate the distance between Sun and Earth, right? We cannot use meter scale. We cannot use a tape scale. We cannot use vernier calipers. We cannot use a screw gauge. Then how to measure? Which method you are supposed to be following? That is indirect method. Okay? Direct method on the way, you have to use meter scale, screw gauge and vernier calipers. Okay? So with the help of these three, we can measure the length directly. But if you want to calculate the distance between Earth and Sun, these instruments are not at all suitable. So where we have to follow indirect methods. Over. Next. Sir, but when you are measuring the length, that length sometimes may be large, sometimes may be small. Then how to calculate measurement of larger distances? How to calculate measurement of smaller distances? So here measurement there are two methods to measure the length, direct method and indirect method. But this length may be large, may be small. So large distances and small distances. So give examples. Right. Examples for large distances. Distance between Earth and the Sun. Right? Small distances. Size of atom or molecule. Okay? Then what are the methods to find large distances? What are the methods to find small distances? This is very, very important. So listen carefully. Students, listen carefully. To measure the large distance, we always prefer indirect method only, not direct method. That method is nothing but parallax method. That method is nothing but parallax method. Okay? Remember, to measure the large distances such as the distance between Earth and Sun, we always prefer indirect method but not direct method, because of with the help of meter scale it is very difficult to find such a large distance. So this method is indirect method, and this indirect method is known as a parallax method. I hope it is clear. The next thing, to measure the small distances such as size of a diameter of atom, size of the nucleus, size of the proton, size of the electron, size of a molecule, size of an ion, how to find? In earlier we are using optical microscope. Later we introduced electron microscope. But nowadays, due to advancement of nanotechnology, nowadays we are using tunneling microscope. We are using tunneling microscope. Right? With this tunneling, with the help of this tunneling microscope, one can easily analyze the size of an atom with more high resolution. Okay? Earlier we are using so many microscopes like optical microscope, electron microscope, but that resolution is not that much heavy, that much high. Nothing but we cannot measure that diameter accurately with more resolution. That's why now due to advancement of this nanotechnology, nowadays we are using tunneling microscope to study small things or to find the small distances such as size of an atom, size of a molecule. So to find the larger distances such as the distance between the Earth and the Sun, we are always preferring indirect method, that is nothing but parallax method. Okay? So these are the methods to find the measurement of length. Right. So tomorrow we will discuss about the parallax method. Right? Now here I am giving only two questions, assignment questions. One is define solid angle, one is define candela.